In a world striving for new frontiers, one vision stands out: colonizing Mars. It's not just science fiction, it's a dream inching closer to reality, thanks to visionaries like Elon Musk. But why Mars? How will this colossal feat be achieved, and when might we witness this historic leap? Could you be among the first Martians? I mean, I hope we are out there on Mars, and maybe beyond Mars, the moons of Jupiter. I hope we're traveling frequently throughout the solar system, perhaps preparing for missions to nearby star systems. I think all of this is possible within 50 years, and I think that will be very exciting to do that. The journey to Mars transcends mere exploration. It symbolizes a pivotal leap for humanity, potentially unlocking mysteries of the cosmos. Imagine fleets of spacecraft shuttling between Earth and Mars, transforming the red planet into a bustling hub of human activity. But the burning question remains: how might we turn this bold dream into a reality? What groundbreaking technologies and strategies will pave the way for our future on Mars, and possibly beyond? Well, at first, you would have to have a life support system because Mars has a low-density atmosphere, only about 1% the density of Earth's, and it's primarily CO2. Now, over time, you can terraform Mars. Terraform means to make it like Earth, essentially. And if you warm Mars up, there's a bunch of frozen CO2 that will evaporate, densify the atmosphere, and you'd actually want kind of global warming on Mars. Mars is about 50% further away from the Sun than the Earth, so it gets about less than half the solar energy that Earth does. It is highly likely that Mars had liquid oceans, albeit a long time ago. There's a lot of ice. Mars is covered in ice, and now the ice is covered in dust mostly, except at the poles. There's a lot of ice. In fact, I believe if Mars were warmed up, you'd have an ocean about a mile deep on 40% of the planet. So it's quite a lot of water. The evidence suggests that it is most likely that Mars had liquid water. Just over time, the solar system cooled. Very early Earth was like molten rock, so really almost nothing could survive in the beginning. We were just a ball of lava. We're still mostly a ball of lava. At surface ambient pressure, we were basically covered in liquid rock, thin crust on liquid rock. Understanding Mars extends beyond just terraforming possibilities. This intriguing planet, with its dramatic canyons, towering volcanoes, and mysterious ancient riverbeds, offers a unique window into the solar system's past. Mars' geological history could unlock secrets about planetary evolution and the conditions necessary for life. It's a world of extremes, with the largest volcano and canyon in the solar system, yet it echoes similarities to Earth's early days. What if Mars holds clues to life's origins or the fate of our own planet? Imagine uncovering fossils or microbial life, proving we're not alone in the universe. The potential for scientific discovery is limitless. But why go to Mars in the first place? Is it for the pursuit of knowledge, the survival of humanity, or the sheer challenge of it? What drives our fascination with this red dot in the sky, compelling us to reach for a world so alien, yet so familiar? Well, I mean, the Mars thing is really, if you say, what is going to be really important to the preservation of civilizational life as we know it, more than just, humanity, because, of course, we bring life as we know it to Mars. And there's no life that we can detect on the surface of Mars. There may be some subterranean bacterial life, but on the surface, there isn't anything. So this would be the extension of life to another planet, or life as we know it to another planet. And I think it would be a huge difference to the probable lifespan of human civilization and life as we know it. So it's sort of like an insurance policy, a life insurance policy of life collectively, and I think it's important that we become a multi-planet species, not a single-planet species, but on another planet. So, really, it's like, what kind of future do you want to have? Do you want to have a future where we are forever confined to one planet, or one where we are out there exploring the stars on many planets? I think the latter is far more exciting and inspiring because the former is basically waiting around until some extinction event. Eventually, there will be one. It might be quite far in the future, but it also might not be far in the future. So, there's really two main reasons, I think, to make life multiplanetary and to establish a self-sustaining civilization on Mars. One is the defensive reason, to ensure that the light of consciousness as we know it is not extinguished or lasts much longer. And the second is that it would be an amazing adventure that we could all enjoy vicariously, if not personally. Musk's perspective offers a compelling narrative about the future of humanity and our place in the cosmos. He envisions Mars colonization not just as a scientific endeavor but as a crucial step for the survival and continuation of life as we know it. This vision goes beyond mere exploration, it's about safeguarding the future of consciousness and life itself. In Musk's view, a multi-planetary existence isn't just desirable, it's necessary, but amidst this grand scheme of interplanetary expansion, one of Musk's more controversial ideas stands out, the proposal to detonate a nuclear weapon on Mars. But why did Elon Musk suggest such an extreme measure? What could be the potential benefits and risks of using nuclear technology in this way? And how does it fit into the broader vision of making Mars habitable for human life? The sun is a fusion explosion. That's what the sun is. It's an ongoing fusion explosion. So if you wanted to add energy to Mars, like warm up Mars, really the source of almost all energy in the universe is fusion. Even fission is, originally, there was fusion, and then later resulted in fission. But what I was really talking about is creating two little suns, two pulsing suns above the north and south pole of Mars that would warm the poles up enough so that the frozen CO2 would gasify and densify the atmosphere. Some of the water would also heat up, and you'd have water vapor and CO2 in the Martian atmosphere, which in that case is good because the CO2 ends up warming Mars up. And so you get a positive sort of reaction, like it's a positive cycle of warming on Mars. Harnessing the power of nuclear fusion to create artificial suns is a concept straight out of science fiction, yet it epitomizes the boldness required for Mars colonization. This approach could fundamentally alter the Martian climate, potentially making the planet more hospitable for future settlers. With these groundbreaking ideas in motion, the anticipation for a manned mission to Mars grows. So the question lingers, when can we expect the first humans to set foot on Mars? Best case is about 5 years. Worst case, 10 years. It's fundamentally engineering the vehicle. I mean, Starship is the most complex and advanced rocket that's ever been made. It's really next level. And the fundamental optimization of Starship is minimizing cost per ton to orbit and ultimately cost per ton to the surface of Mars. This may seem like a mercantile objective, but it is actually the thing that needs to be optimized. Like there is a certain cost per ton to the surface of Mars where we can afford to establish a self-sustaining city, and then above that, we cannot afford to do it. So right now, you couldn't fly to Mars for $1 trillion. No amount of money could get you a ticket to Mars. So we need to get that above, to get that like something that is actually possible at all. We don't just want to have with Mars flags and footprints and then not come back for a half century like we did with the Moon. In order to pass a very important great filter, we need to be a multi-planet species. It sounds somewhat esoteric to a lot of people, but eventually, given enough time, the Earth is likely to experience some calamity. It could be something that humans do to themselves or an external event like what happened to the dinosaurs. Eventually, if none of that happens, and somehow magically we keep going, the sun is gradually expanding and will engulf the Earth. Earth will probably get too hot for life in about 500 million years. It's a long time, but that's only 10% longer than Earth has been around. So, if you think about the current situation, it's really remarkable and kind of hard to believe. Earth's been around 4.5 billion years, and this is the first time in 4.5 billion years that it's been possible to extend life beyond Earth. That window of opportunity may be open for a long time, and I hope it is, but it also may be open for a short time. We should act quickly while the window is open, just in case. Civilization could die with a bang or a whimper. These are all risks. It's important to think of these things in terms of probabilities, not certainties. I think most likely the future will be good, but there's, let's say, for argument's sake, a 1% chance per century of a civilization-ending event. That was Stephen Hawking's estimate. So, we should think of this like being a multi-planet species, just like taking out insurance for life itself. We can bring the creatures, plants, and animals from Earth to Mars and breathe life into the planet, and have a second planet with life. That would be great. They can't bring themselves there, you know, so if we don't bring them to Mars, then they will just